This is Unit 6, which is Chapter 10 for Algebra 1. This is on factoring. This is the second video from page 637. We're going to do numbers 26, 27, 30, and 31. So 26 and 27, both of these, the first thing I noticed is that they are two terms. So these more than likely are going to be difference of perfect squares. Remember, you should always be looking for a greatest common factor first when you do these problems. 26, there is not a GCF because there's no x in the second term, and there's no number in the first term that besides for 1, which we're not going to use as a GCF. So when I look at this, I notice that it is a squared, I notice that it is a minus 196, although it's not a perfect square that we use a lot, is actually a perfect square. It's going to be 14. So 14 times 14 gives me that 196. And it's a plus 14 and a minus 14. Number 27, very similar, but for this one there is a GCF. So 16 and 36, we have to start to think about is, okay, what can go into that? And 2 definitely goes into it because they're both even. 4 can go into it. 8 can go into it. And you almost really should start backwards and really start with 16 to 16 go into it. It doesn't. So I'm going to take 4. I'm going to take 8 out of, actually, I can't take 8, sorry. We're going to take 4. I think I misspoke earlier and said 8 goes into 36. It does not. So again, I typically start with the highest one. So 16 doesn't go into it. 8 doesn't go into it. Actually 4, it does go into that. So when I take out my 4, I'm left with 4x squared minus 9. So again, the greatest common factor there is 4. There's no x's that I can take out because the second one does not have an x. And this 4x squared minus 9 is now, again, the difference of perfect squares. Both 4 and 9 are perfect squares. So when I do this, very similar to 26, but this one we're going to have a number out in front. The square root of 4 is going to give me 2, so it's 2x. Of 9 is going to give me 3, so it's 2x minus 3, and then 2x plus 3. By the way, I should mention as well, one of the ways you know that you're finished factoring is when you don't have any squares left over. Now, just because you have a square left over doesn't mean you can factor, but when you don't have anything besides 4, when you only have an x of the first term left over, you know that you absolutely are done factoring there. Okay, so for all of these, there are no x squareds, x to the thirds, etc., so we are finished. So moving on to number 30 here, we have 4x squared plus 144x plus 121. If you notice that 4 and 121 are perfect squares, then you might know that you can just make this 2x plus 11 and 2x plus 11. Most people, I'm assuming, are not going to notice that, all right, especially when this is just dumped amongst other trinomials. So what you're going to do is take that 4 to the 121. This is x squared plus 144x plus 484. Actually, now I just want to double check here. I think I have the middle number incorrect. So this should be a 44, not a 144 in the middle. Okay, so I'm going to take away that 1. So x squared plus 44x plus 484. So now I'm going to look for numbers multiplied to be 484 and add together to be 44. So 44 actually breaks down into 22 times 22, which would give me the 44. All right, since it's a plus at the end, that means both these signs have to be the same, and they're both going to be the middle one, which is just a positive. So they're both plus 22 there. And I have to divide by that 4 that I multiplied by. When I do so, I'm left with x plus 11 over 2 for both of these. So really it's x plus 11 squared. So when I go to the next step, when I kick this 2 back out to the front, I'm going to have 2x plus 11. And I'm going to leave it as 2x plus 11 squared. All right, number 31. Again, looking at a trinomial, when I look at this, we should always, again, look at a GCF first. I think I failed to mention that for number 30. Okay, there was no GCF in number 30. In number 31, there is. I can pull out a 2. These are all even numbers. So if I pull out a 2, I'm left with x squared plus 14x plus 49. And I'm looking for numbers that multiply to be 49, add together to be 14. That's going to be x and 7. And 7, they're both going to be a plus. So this is 2 times x plus 7 squared. So if you notice, this section, this video covered all the special ones. So the first two, number 26 and 27 was the difference of perfect squares. 27, there was a GCF. 30 and 31 aren't difference of perfect squares, but they're considered special because these answers come out to have the same exact numbers in the binomials.